chair move.
That way.
Therefore, the friction acting on the chair is
To the right.
And then work back this way.
Now, there is another indication of whenever you're doing this, if acceleration is to the right, and we assume it's all accelerating together. If acceleration is to the right, there has to be a net force in that direction. Up until I put friction down, I had no force acting to the right on the chair. So at some point, it has to come in. There has to be some force to the right there has to be a net force on every object to the right, except the ground. All right. So that's that one. What about box and truck?
The friction would be towards the right on the box.
Okay. And again, I have no forces acting to the right, so I got to have something accelerating in that direction. So I've got friction there, and that's nice. I think those marks are for my sleeve. And I'm just going to put it over blue there. We've already gotten that friction of S of H and S of H. All right, Edro and the board. Sorry, Garog and the board. Actually, what is the friction force between Edro and the board? Right, okay. Now, Garog and the board.
The friction would be to the left.
On
Garog. No.
Left on the board.
It is on the board. Right. So there's friction.
Yeah.
So what was the final yeah was
So
for
that one to the right. So it would be to the left. Yeah.
left on
Garog.
and then right on the board?
Yes.
If the friction on the board were to the left, then it has no force accelerating it to the right. So there has to be that is correct. If the board were frictionless or the feet were frictionless, and the truck goes, then he would just slide that way. So friction is trying to prevent that. And we've got two more pairs. We got that, and that. We don't have edge-row and chair, and we don't have truck and ground.
Friction against the truck would be to the left
Why?
because it's accelerating to the right, so it'd be against.
So what force is, so if it's to the left here,
Because it's going against the direction that the truck is accelerating in.
then what, if it's accelerating to the right, there's gotta be a force to the right. What force is acting to the right then?
There isn't one.
It accelerates to the right by magic. Which way is friction acting on the truck?
The right.
It is acting to the right. Now, how does that reconcile with what we talked about? Because as you said, the truck wants to move that way, therefore shouldn't the friction be acting this way?
The friction would be from the ground, so the friction on the ground would be to the left, and the friction.
What part of the truck is the friction acting on?
Tires.
Tires.
Which way did yeah. The tire wants to move like this. At the point of contact, the tire wants to move that way. The ground is opposing the motion of the tire at the point of contact. So there is a friction force acting this way on the truck because the tire is spinning around like this. It's four-wheel drive, so all four of the tires are trying to spin clockwise. And at the point of contact, that means the tire wants to spin that way, so friction is acting opposite that. So F sub T and then F sub T. And have you ever been stuck in the mud? And what happens when you gun the engine, when you're stuck in the mud?
Spin.
What happens to the mud?
Swings backwards.
Yeah, this is the force right here, which kicks the mud backwards. Another reason, because if you're on a frictional surface, if you're parked on ice and you want to start moving, it's very difficult to do. So it's definitely lowering the friction. If friction were acting back that way, lowering the friction might mean it's going easier for you, but it's a lot harder to get moving. All right, and now hedgerow and the chair.
Going to the right on hedgerow.
So this way on hedgerow,
And then the left on the chair.
yeah. Or, no.
Either way.
The reason, if he's got a grip on the stick, he could pull himself forward with the stick. So as he grabs onto it and he pulls this way, he could move himself forward, in which case friction would be acting in the other direction. If he's just, lightly pushing on it, then most likely it's the chair that needs to be sort of propelling him forward. So this is the intent right here, but you could make an argument that friction's going the other way depending on how hard he's pulling on the stick. And if you're unsure, just think about when you're driving, you have your hands on the steering wheel, you could pull on the steering wheel towards you, which would shift your body closer to the steering wheel. So, I think we are done. That is a test level problem. Questions? That's a good enough place to end.